So this is another example of supernodes. Here it's a weird circuit, but again we're going to find ground, which is the first step in nodal analysis. In this case I'm going to put ground here. So this whole node here will be ground, and then you see the IA. A lot of people ask me, what's the current IA doing there on ground? But you see it's the same current that's coming down here, and therefore I'm going to put this IA over there, going in that particular direction. For the second step, we're going to label currents and nodes, except for ground nodes already here. And here is a IB, for example, and then I'm going to call this V1, V2, V3, V4. So I have 4 nodes other than ground. And then I'm going to find all voltage sources, hoping to simplify the circuit. And the first thing we see here is this minus 5 volts, so I know what V4 is. Basically V4 minus 0 equals minus 5 volts, so V4 is minus 5. And then I see other voltage sources here, which are connecting V1 to V2 and V2 to V3. So this is a super node. And I can write equations that connect these 3 nodal voltages. So the supernode composed by V1, V2, and V3 will have the following equations. First, V2 minus V3 equals 2 volts. I'm just going to write 2 for math purposes. And now V2 minus V1 equals this 0.3 IA, 0.3 times IA. And I'll find IA in a second. The only KCL that I expect you to write for this whole circuit is the supernode KCL, because we already found V4. We already found how these nodes connect. So the only KCL is for the supernode. And from the supernode's perspective, I'm seeing here what's crossing the green. IB is coming out. 90 milliamps is coming out. And IA is coming out. So nothing's coming into the supernode. IB plus 90 milli plus IA. This is the KCL I'm expecting. And this is step 4 in my how-to for nodal analysis. Find these sources, simplify KCL, and now all that's left to do is to write Ohm's law. So we're going to write Ohm's law for IA and for IB. IA is V3 minus V4 divided by 300. Now V4 I know is minus 5, so it's going to be V3 plus 5 divided by 300. IB is V1 minus 0 divided by 100. Now what happens is that I'd like to write IB as a function of U1. IA, I would also prefer to write as a function of U1. So I'd like to see V3 as a function of U1. So I'm going to subtract those 2 equations. So equation 1, possibly minus equation 2. Which is going to be minus V3 plus V1 equals 2 minus 0.3 IA. But now I know that IA equals V3 plus 5, so V1 minus V3 from here equals 2 minus 0.3 times 5 divided by 300. So I can divide both by 3. and 0.1 over 100 is 1 over 1,000. And then 5 over 1,000 is 0.005. I almost have V1 as a function of V3. V1 equals 2 minus, okay, plus V3 plus 0. So this is my V1 as a function of V3. And the reason I want that is that I'm going to put, maybe I want V3 as a function of V1. The reason I want that is that I want to write this as V1 over 100 plus 90 milliamps plus IA is V3 plus 5 divided by 300. So I'm multiplying everybody here by 300, which is the least common denominator. So it's 3V1 plus 9 times 3 is 27. And then this is 10 to the minus 2 times 10 to the 2. Cuts it off. Whoopsie, equals 0. Now, either I use one or the other. So basically I have V1 here. So I'm going to use V1 on top. So I need to multiply V1 by 3. So I'm going to say 6 minus 3V3 divided by 1K plus 3V3 plus 0.015. Now I go back to the 27 plus 5 is 32 plus that 1V3 there. All this equals 0. So now I have one equation with V3 and a ton of numbers. So I'm gonna make all the V3s together here. There's 3 here, there's 1 here, so it's 4. And this is 0.003, so it's 4 minus 0.003 V3 equals, it's 32 plus 6 is 38 plus 0.15 is on this side minus 38.015. But I don't have a calculator in the exam, so I'm going to say that V3 is approximately 38 divided by 4. Now 38 divided by 4, you need to know how to calculate even without a calculator. So 4 times 9 is 36. And I have 2 to divide by 4. 2 divided by 4 is half, more or less. Except I forgot a minus here. Right, this minus here. Now, this is V3. I don't know if you can see up here, but I'm gonna try to write here. In another color, how to find IA. IA is V3 plus 5 divided by 300. So IA is approximately minus 9.5 plus 5 divided by 300. IA is approximately minus 4 divided by 300, which is approximately minus 1.3 maybe. Minus 13 milliamps. 4 divided by 3 is 1. Another 1, yeah. Minus 13 milliamps is approximately what I'm looking for when I'm asking you to find IA.